Good evening, everybody. It is my pleasure to be in front of many stalwarts of geotectonics and structural group of India. And with the invitation of your group and Shantanu Bose, I'm really delighted to deliver a simple, small lecture of the tectonics of Kachchh Paleo-rift Basin. Let us start with a simple story of Kachchh. Like the tectonics of Kachchh Paleo-rift Basin is not a very small topic, but I would like to present within a few minutes, maybe 40-50 minutes. I don't know whether I would be able to deliver everything or not, but all major aspects I will cover mostly. Let us look at the overall Kachchh Basin. If you can see the satellite imagery of the this area, western part of India, the yellow colored major patches, which you can see this. If you can see my cursor, these yellow colored are all uplifts, and the blue color ones, they are the depressed region. We call it a great run of Kutch, and this is the uplifted regions. So physiography, first we must learn the physiography before we go to the tectonics and structural aspects of the Kutch Basin. Physiography is very important because the Kutch is the only place where we can say the physiographic features and geomorphic features which runs with the tectonics. So most of the tectonics elements, they have very direct effects on the morphology. So for the structural, for the geomorphic aspects and the tectonic geomorphic aspects, Kutch is one of the best place to study. So these uplifted regions, like there are three major uplifts. One is the Kutch mainland, this is Wagad uplift, and the island belt uplift. Let us look at a very small basin, which is just 200 kilometers north-south and maybe 300 kilometers east-west. And the basin is mostly located on the east-west axis. So this is a major observation. First, I would like to show you the upper part of the Kutch Basin. This is actually Pakistan, and if you can see this area where you can see small lineaments, which is east, northeast, southwest lineaments, but these are not lineaments, they are all sand dunes. So we call it the Thar Desert, and this is Indus Basin. So this is Pakistan, and this is a very, very distinct boundary between Pakistan and India. So this is actually the political boundary, which is also running with the geological boundary, and which is also running with the geomorphic boundary and tectonic boundary. So you can see the sharp line between the Great Run of Kutch and the Thar Basin. Okay, so if you look at the geotectonic aspects, this is one of the major fault, which is called the basin bounding fault, and it is called the Nagar-Parker fault. So Kutch Basin is between Nagar-Parker fault and North Kathiawar fault in the south. So let us look at this geomorphic aspects with the titles. I think with these titles you can understand the geomorphic regions, which is very important for the geologist or tectonogeomorphologist, neotectonic people. Those who want to learn anything in Kutch, they must learn first this geomorphology. The coastal plains, which has several different aspects. In the kind of eastern part, we have mudflat systems. Western part, we have also creek and mudflat system, and in the middle part, we have the sandy dunes, coastal dune systems. The large, very distinct portion in the geomorphology is the Great Run of Kutch. In entire Kutch district and Kutch Basin, more than 20,000 square kilometer area is covered by the Great Run of Kutch and Little Run of Kutch. And less than 15,000 square kilometer area, which is rocky uplifts. So this is mainland uplift, Wagad, and island belt uplift, which is 4 discrete islands. They are actually the rocky uplifts. We'll discuss why they are rocky uplifts and why they are discrete in the later phase of the lectures. Okay, but I would like to give you one very beautiful example, the Kachchh, K-C-H-C-H-H, or Kachchh, which is the word came from Sanskrit language, and the meaning of Kachchh is tortoise. The tortoise, in the sense, the Kachchua, in Hindi language, it's called Kachchua. So if you see the Wagad upland, which looks like the head of the tortoise, and the mainland is the entire body of the tortoise, which is floating upside down into the onto the Gulf of Kutch or Arabian Sea, and these are their hands. So look at this picture. The Kachchua is kind of upside down. We don't know this. Actually, this name came 2,000 years ago, and how the people 2,000 years back, they have given this name, whether they would have the navigational system to see just what we have these satellite pictures. We don't know, but these are big questions that they might have good navigation systems. Okay, before going into the each and every faults of the Kachchh Rift, we should understand the surrounding Western India, surrounding rift systems, and surrounding maybe older and younger rifts of the Western India. Look at this K.S.K.V rift, which is very young in the sense it developed post-Cretaceous, Narmada, pre-Cretaceous rift, and Kachchh. Basically, this rift, Paleo-rift, developed during the Gondwana breakup. So just to compare the size and the time period where different rift system formed in the Western India, we must this particular work has been actually done long back in 1987 by Dr. Biswas. Look at this Kachchh rift with relations to the K.S.K.V rift and Narmada rift. Why this figure is very important, that the K.S.K.V rift is following the trend which is we call the Precambrian trend, that is Dharwad trend. The Kachchh rift, which is following the Delhi trend. This is broadly taken into consideration, but looking to the trend of the Kachchh faults today, east-west trending Kachchh faults, most of the basin bounding faults, this Delhi trend is more appropriate. Okay, so the origin of the Kachchh basin, Kachchh Rift basin, is very important from the point of view that Delhi trend made the weaker plain in terms of the western part of the Aravalli Craton. So basically, the basement of the Kachchh Mesozoics. Okay, if you look at the basement of the Kachchh Mesozoics, they are mostly Aravalli's granites. So that is already proved. So Aravalli granites are the part of the Aravalli Craton. So the Aravalli Cratons had a very weaker plains along the Delhi trend. So this is basically the origin point of the Kachchh Rift basin. So to understand the Kachchh Rift, we must go back to the Gondwana rifting systems. Okay, so this Gondwana rifting, everybody knows this latest plate tectonics around late Triassic period. We have this the rifting and drifting. So our major interest is rifting in the western part of the India between Madagascar and the Africa and India. So this is the origin of the rift system of the Kachchh Paleo-rift system, what we see today. So the importance over here, I would like to say that if today we want to see this kind of 200 million years old environment, if we want to see today, we must see the Great African Rift Valley, where the two continents are today separating. So if you want to look at the old 200 million years or 190 million years old Kachch, we must see critically the Great African Rift Valley. I will come to that point in the later part, but this is how the Rift Valley system occurred and how the basin generated. Okay, so the lava comes up from the divergent plate boundaries, and we have a new, at particular this place, we have a new plate, which is called oceanic plate generated. But what is happening to this continent? This continent has several normal faults, which is towards the faults are dipping towards the ocean or towards the ridge. Okay, but the major issue or major point which I would like to stress upon here, that these small blocks which occurred due to this faulting, these fault blocks are tilted towards the continent, and that is very important to store the Mesozoic sediments in the early phase. So this is how the rift generated, and we have a tilted or rotational blocks, the faults which are a kind of listric or stretching normal faults has a curvilinear fault systems, and the blocks which are tilted towards the continent. And these are early sediments. What early? It's a middle Jurassic to early Jurassic sediments which deposited in the kind of the basin, which I will give you the exact Kachch model in which you would be you would imagine in the proper manner. Let us look at this, the Sin rift sedimentation. What happens to the early rifting systems? So during the rift, we have the first small graben developed, which is called the Run graben. Today, where there is a great Run of Kutch, which is basically a small graben. It is not half graben, but the graben. So in that graben, you can see here the Nagar Parker uplift is at one side, and Nagar Parker uplift is giving the sediments inside this the graben, which rarely gets the sea influence of the sea. Okay, but there are so much of the fluvial aspects and the kind of alluvial fan system developed in this particular small graben. Okay, the evidences of those small grabens we will see later on. So in the Sin rift sedimentation during the late Jurassic, mid to late Jurassic, we had a small Run graben, and later on there is a half graben which is called Bunny and the Gulf of Kutch half graben developed. Okay, where we have other sediments, that means the later Jurassic sediments. Post rift sedimentation, where the we have not shown here this graben, but the BHG Bunny half graben and the Gulf of Kutch half graben divided into two during the post-rift sedimentation. And in the post-rift sedimentation, they have the Sin rift marine sediments and post-rift marine sedimentation. And there are post-rift and post-early Cretaceous fluvial sedimentations. So this is having a two major segments, Bunny half graben and the Gulf of Kutch half graben. Okay, so this newly generated, it is not newly generated Kutch mainland fault. It was there in the basement. These all faults, Island Belt fault, Nagar Parker fault, Kutch mainland fault, and North Kathiawar fault. These faults were there in the basement, but during the sedimentation and the post-Cretaceous upliftment, these faults were reactivated, and reactivation of the faults as well as the sedimentation, here it is both together. So in the post-rift sedimentation, the reactivation of the faults as well as the sedimentation, they were working together. In the Cretaceous, end of the Cretaceous time, as everybody knows that the Indian plate was moving over the reunion hotspots, and that point is great volcanic eruptions and also igneous intrusive activities all over India, and at the same time it was in the western part of India, in Kachchh as well as in Saurashtra. So that has given rise to the large scale lava eruptions and the intrusive activities in the domes, because the ridges were coming up along the faults. So these ridges have several dome systems. These domes are intruded with the laccolith systems, and several dike systems also came into the pictures. And this cross sections is the today's tectonic as well as the sedimentological picture of the Kachchh Basin. This we will take it later. Just let us look at the today's tectonic pictures. So with the help of the major tectonic maps, with this small understanding of the origin of the Kachchh Rift, I think we can understand now clearly the aspects of the Kachchh tectonic maps as well as intricate structural maps also. So the North Kathiawar fault, Nagar Parker fault, and Island Belt fault. See, Island Belt faults have several. It is divided into several pieces. It is dissected by the transverse fault systems. These transverse faults came into the picture not in the Pleistocene time, but right from the origin of all these secondary faults. So in terms of the secondary faults, when basin started inverting, these faults also started coming into the picture. So there are importance of these transverse faults in shaping the landscape of Kutch, so that you can understand this how they discretely separated islands. And here also the transverse faults, they have separated several dome systems. Okay, this is older. As you move from the top to down, north to south, you get the older, this get the older topography, this is younger topography, and this is youngest topography. So the signatures of the latest faults, it is more preserved in the Katrolil fault, less preserved in the Kutch mainland fault, and almost buried island belt faults you will see. So you don't get very many signatures of the latest faulting systems or neotectonics also. Okay, so as such, the island belt fault is very old fault, and it is not very active fault in terms of the Katrolil fault and Kutch mainland fault. Okay, so this is another picture where you can see the tectonic geomorphology quite clearly. So this is summing up of the basin evolution. We must start with the Gondwana fracturing. I'll go quickly. The Triassic period, Gondwana fracturing, then rifting and drift basin formations, early Jurassic, then rift sedimentation, that is mid to late Jurassic period, drifting and continental deposits, that is in the Cretaceous period. So we have the very rapid drifting started in the late Cretaceous period. And we have in the Kutch Basin, the continental depositions in terms of the Bhuj formations. So that is very significant sedimentary basins, sedimentary facies. Then at the end of the Cretaceous, we have a Deccan plume volcanisms. After that, another episode of the sedimentary episode started, which is called the tectonic episode is a sagging and sag basin formation. And then in the half graben embayment, that is open sea basin, we have a large tertiary Eocene to Oligocene Miocene formations started depositing. That is called the marine transgressive regressive sediments. And then at the end of these sedimentations, it is not at the end, but this rift inversion started with the advent of the tertiary period itself. So we have the rift inversion. In the rift inversion, we have the Mesozoics as well as the early Cenozoic, that means Paleocene sediments, they inverted. Then half graben formation, what we see today is the picture of the Quaternary's tectonic activities, and that we have the half graben formations, and then formation of the today's Bunny, Run, and the today's major uplifts. What we see today's topography is the result of the Quaternary tectonics and of course climatic activities. So now going back, before this we have seen the history of entire basin, tectonic and stratigraphic history, but we must learn the very basics of the two major phase of the tectonic and sedimentological evolutions. So just to classify the tectonic and sedimentological evolution, we must learn the two major cycles. The earlier cycle, during the rifting phase, we have the interior fracture cycle. That interior fracture cycle came into the picture during the Jurassic period, and it has even continued in the lower Cretaceous period. With this cartoon, I think you can understand our interior. Can you see, sir? Is it okay? Can you see each and every slides?
It is perfect.
You can see the slides. Okay. Yeah. So in the interior fracture cycle, we have the blocks, continental crustal blocks. They were tilted to the towards the continents. But in the later phase, in the sense after the interior fracture zone, this is the period, interior fracture zone period, where we have got a marine interventions in the rift basin. So it is a rift cycle, and this is actually open marine cycle. So we call it the tertiary sedimentation cycle or marine sag cycle. So this is overlapped. Marine sag cycle is overlapped, overlapping the interior fracture cycle. Because this oceanic basalt, newly formed basin, which we have given here just one end, because we are seeing the one end only. So here the tilted blocks, they are, if you can see in this cartoon, the tilted blocks, continental tilted blocks. Earlier it was tilting towards the continental side. Now they are tilting towards the open sea side. So that is the basic understanding of the open sea embayment systems and marine sag cycle during the tertiary. So these are the two cartoon systems which can give you the overall idea of the two major sedimentary cycles. This is the same thing in a different types of, both is together. The A and A is a middle to Jurassic, middle Jurassic to Cretaceous. B is the Paleogene cycle, that is the open sag basin cycle, and C is the Neogene open sag basin cycle. So you can largely understand with this cartoon that this open marine system has Neogene cycle, and which is continued till in the oceanic basin. And if you can see open sea of Kachchh offshore, we have these sediments, Paleogene, that means the Miocene, Oligocene, Miocene, Pliocene sediments, as well as these sediments, Neogene, Paleogene sediments also, they are there in the oceanic offshore of Kachchh. Okay, so this is all together here I have shown you, and here this is with respect to the Kachch Basin. This was earlier was the overall ideal picture of the marginal sac basin systems, but here with respect to Kachch, one can now understand how the basement is fractured here and where the rift system Jurassic is deposited, rift fields deposits, and marginal sag basin deposits where we have Cretaceous, early Cretaceous to tertiary systems. So this is also based on the data of the ONGC's well logs. Very long back, maybe I think it is 1965 or 70, they had 4 well logs, and based on that well log data, this particular cartoon has been generated, which we call it a polycratonic polyhistory basin. So Kachch is not very simple what we see. It has complicated tectonic basins in terms of the major geotectonic evolutions. So when we learn about the tectonics, we cannot leave aside the sedimentological evolutions, because the sedimentary basins generated due to these tectonic movements. So both the things run side by side. That is why we have incorporated the all sequence details over here. So based on the now, just look at the map of the Kachch. Only Jurassic map we have shown here. That means Mesozoic, not even Cretaceous, only Jurassic systems, which is called Kachch, that's a rift filled sediments. Because the Cretaceous has several Cretaceous, upper Cretaceous, they are open systems, open embayment systems. So this is called the rift basin map, and this is total. So in the total geological map, one can see the rift field sediments and the sag field sediments. Sag fields are mostly the Neogene and Paleogene, which is separated by the Deccan Trap. You can see clearly a Deccan Trap patch between these two major sedimentary cycles. Now, in terms of the lithostratigraphic classification, which is shown here based on the Biswas classification, I think this is much more accurate and correct in terms of the sedimentary evolutions and basin tectonics. The classification is divided into 3 major lithostratigraphic units. One is a Kachch mainland unit, the other is a Pachcham unit, only Pachcham units, and the third one is these 3 islands, Khadir, Bela, Chorad, and the Wagad Island. So this unit is different, lithostratigraphic unit. This is different. So the classification of each is given over here. The oldest in the Kachch mainland is Jurio formations, which may be equivalent to the Kaladungar formations. Okay, and which may be equivalent to the lower part of the Khadir, upper part of the Khadir formations here in the eastern Kachch basin. So it is Jurio, Jumara, Juran, and Bhuj. The many of the scientists, they follow the earlier classification, which is chronostratigraphic classification. According to that chronostratigraphic classification, they have given the overall classification of the Kachch basin, excluding the lithostratigraphic or lithological changes. In the same period, there are several different lithologies in all 3 different lithostratigraphic regions. So for them, they have the Pachcham, Chari, Katrol, and Umia and Bhuj formations. But we have not given stress upon this chronostratigraphic based on the purely biological evolutions. Okay, and then it is a Deccan Trap overlain by the Deccan Traps. And here in the western Kachch, we have a large sediments, thick sedimentation of the Tertiary period, Paleocene to Eocene, Oligocene, Miocene, and Pliocene. And Pleistocene deposits as well as recent deposits, the Run of Kutch is totally recent deposits. Maybe somewhere it is 50 meters, somewhere it is 500 meters. Pachcham has 2 major classified Kaladungar and Goradungar formations, while the eastern part of the lithostratigraphic unit has a Khadir formation, Vastava, and younger one is Wagad sandstone. Wagad sandstone formation is equivalent to the Bhuj formations. They are all the continental deltaic systems. Okay, so this is a little bit of understanding of the geology I would like to show to everybody. Since the geology, since the tectonics is not only run alone, the sedimentation is the part and parcel of it. So that I would like to show, and this is of course in the column you can see the different mainland group, Pacham group, Khadir and Wagad group. Okay, so I am skipping all these things, but now this is the latest scenario, latest present geometry of the Kachch Basin. With this geometry, one can say take one by one from the North Nagar Parker Fault to IBF to KMF. Let us look at now, we have one terminology, Nagar Parker Fault and IBF. Between these two faults, we have a large run graben. If you can see, everybody, run graben. Between IBF Island Belt Fault and Nagar Parker Fault, there is a run graben, which is first to come into the picture during the rifting phase and which is first to fill the sediments. So what kind of sediments they are made up of, which is now today you can't see, mostly you cannot see, which is totally buried under the Great Run of Kutch sediments. That is a recent sediments of the run sediments. So there are some small outcrops which I would like to present to all of you. Recently, we have found those outcrops, which are very important to tell the evolution of the Kutch Basin. Now, the first phase, I will take this. Second phase, IBF to KMF, IBF to Kutch Mainland Fault. If you can see minutely, from IBF to KMF, the sedimentation or the basement which is tilting, if you can see, the basement is tilting towards the south. This is south. So this I can say, or we can say, is half graben, and presently this particular half graben is filled by the bunni. Bunni is a bunni grassland, so that is why we call it a bunni half graben. This is half graben, mind well, this is a graben, half graben. Now, look at this fault and its nature. This is a kind of down-thrown side, this is up-thrown side, this is a footwall, this is hanging wall, this is kind of normal system. But here, this basement is again tilting towards south. So we have another half graben right from the Kutch Mainland Fault, and this particular uplift is having a northern hill range. This is hill range. Here we have a island belt hill range along the island belt fault. So this is another half graben which you can recollect. I have shown you in a small cartoon of the three-dimensional image. So this half graben is continued to the Gulf of Kutch. So that we say this half graben is called Gulf of Kutch half graben. Okay, so this is present day tectonics as well as the sectional picture wherein you can see the nature of the Kutch Mainland Fault, wherein you can see the nature of the Island Belt Fault, kind of normal this way, and the newly generated, that means during the rift inversion, this fault is newly generated, which is called KHF, the Troll Hill Fault, where you can see very clearly that this block, which is called the Gulf of Kutch half graben block, which is thrusting over this block. So it is again this Gulf of Kutch half graben is divided into two segments, which is a later phase. Maybe this particular thing happened in the late maybe Neogene period, early to middle Neogene period. And most of the development of thrusting occurred in the late Neogene period. So this picture I would like to print in your mind to understand the basic nature of the Kutch Basin. Wherever you come to Kutch, this block, this particular picture must be in the mind. Now, another thing I would like to focus on this particular thing, that any of the fault you see here, KMF or Bunny, NKF or any of the faults, they are basically basin bounding faults. These are all basinal faults, not this one, not particularly these small faults, but these are basinal faults. Basinal faults mean they are the basement tectonics must be understood to understand the whatever you see on the surface. So on the surface, sometimes if you see in a very small picture, like there are some 25 domes along this particular hill range. So if you see this hill range, you have got several different nature of the splaying nature of the main Kachch mainland fault, where you get north dipping, you may get a south dipping. So if you are moving in this area, we call them fault zone area of the Kachch mainland fault, you may find several of them, several faults. But sometimes you misguide due to their nature on the surface, because this particular north dipping or south dipping or vertical faults, it is exactly on the surface. It is not the nature which is basically in the basement. So it is kind of the flowering structures. When fault comes on the surface in the sediments, sedimentary cover, it may be kind of splaying and flowering. So it is a kind of flowering. So each and every domes have such kind of flowering structures are present. So now let us go back to this particular NPF. That means run graben system. So in the run graben system, I take from the northern part. Look at this run graben. I think with this picture you can have the Nagar Parker uplift and the island belt uplift. And between island belt and Nagar Parker, there is a large great Run of Kutch. But in this large great Run of Kutch, there is a very small, maybe 90-meter long and 80-meter wide. This is 90-meter long and 80-meter wide small hill, which is made up of the syenite, and it is called the Meruda Thakkar. So recently we went there after maybe 35 to 40 years, when Biswas went there in 1965 on the camel back, and we used 10 my colleagues and my other research students, we used motorbike, and we reached there in the dry area, dry phase of the season. What is important here is this is syenite exposures. Syenite, in the sense, it is very much equivalent to the Aravallis, Precambrians of Aravallis. So this could be a remnant of the Merudas, or that means remnants of the Nagar Parker hills. Okay, because whatever the sediments we got here in the Kachch Basin, they are all generated from the hinterland areas of the Aravallis, and this is one of the remnants. So it could be one of the uplift, intra-basinal uplift in the run graben, and that is still present over there. And it is very important to show you this picture in a actual site. This is that actual site, just to show you the picture. So you can imagine a very small hill, and either is in a desolate run. It is very interesting to find. We are now going for the dating of particular this the syenite, whether it is Precambrian or it is kind of early pre-Deccan activities, but it is still question. But as per the Biswas model, it is Aravallis exposures. Now, coming to the south, little bit of south. If you see the Khadir Island, that is Island Belt Fault, this is a Khadir scar. Just north of this island, just north of this Khadir Island, we have a small exposure which is called Cheria Bed. And if you, I have zoomed here the Cheria Bed, and we have given the, I have given here some of the field exposures. You can see the Cheria Bed conglomerate. This conglomerate is very important. Why it is important? Just look at this Run Graben. The Run Graben has received the sediments from the Nagarparkal uplift, mostly Nagarparkal uplift, in the form of the fluvial systems, alluvial systems, colluvial systems, and there are major fan systems developed over which the over the sloping basement. So this conglomeratic horizons in the Cheria Bed, which is having several big blocks to small sized, not very much rounded, and mostly angular boulders and fragments of Malani rhyolites to gabbros to cyanites, and most of the Aravalli system, the rocks of the Aravalli systems, they are found in this conglomerate. So this is proved that the Run Graben received the colluvials and alluvials, which now you can correlate with the Great Rift Valley of Africa, where today, if you go there and see from two ridges of the banks of the river Nile, the colluvial fan and alluvial fan systems, both the sides, which is very equivalent to this kind of conglomerate. So present is the key to the past. So present, you can see the analog is in the Great Rift Valley. Here, this is the only place where we got the dinosaurian bones, because that time this was open. In Jurassic period, this was open, that means the continental part where the animals used to move. So maybe the dinosaur used to move on this Nagarparkal or the Aravalli Rift ridge systems, and that is why in this conglomerates we have the bones of dinosaurs. Okay, this is already proved. I think I don't know the name of that dinosaur, but there is a dinosaurian bone, and there is a paper over it. Now, looking coming down to the little bit of south in the island belt uplift. So this is the nature of the island belt uplift along the island belt fault. This is north, this is south. Here this is north and this is south. So this island belt uplift, this is Kaladungar Scarp, and here it is a Khadir Scarp. This IBU, that means island belt uplift, which has the sediments and the block, basin block, which is tilted towards the south, and the scarps are facing towards the north. So we are not going into the details of the what kind of sediments, but the Kaladungar sediments, Goradungar sediments, and the Khadir sediments, they are seam rift sediments, overlain by the fluvial, which is not here preserved. In the south, they are preserved. So now going more to the south, coming to the Kachchh mainland fault. Now we see this picture, Kachchh mainland uplift. Kachchh mainland uplift is very interesting in terms of the structures and tectonics. And that is how I think I have given more slides on Kachchh mainland uplift, because along this Kachchh mainland fault, there is a 150-kilometer long continuous or discontinuous Kachchh mainland ridge or northern hill range, which has several structural domes of various size. It may be a small circular to larger kidney-shaped, elongated, several different sized domes are there. And to the north of those domes, there is a Kachchh mainland fault, and at many of the domes, major domes or minor domes, there are intrusive bodies. So this is a clear picture of SRTM view of one of the domes, two of the domes, Habo Dome and Jura Hill, which one can easily see the domal structures of Habo and domal structure of the Jura Hills. Kind of this is just mimicking the onion. If you cut the onion, you can see the layers in the onion. Similarly, you can see the layers on this outcrops. So middle part, the middle one is older in layers. Okay, so this is very clear in terms of the tectonics and the structures, but we must learn how these different domes have been originated. So it is still under the research. Let us look the other pictures, other domes. There are maybe 20 domes, major and minor. In all, there are 20 domes. This is one of the small, very small, 1.5 to 2 kilometer long dome. It's called Gunnery Dome. Look at very clear picture of the Gunnery Dome and structures of the Gunnery Dome, almost elongated. And on one side is bounded by the Kachchh mainland fault. Okay, it is also like onion structures. This is one of the very interesting dome, and I think it is a world famous dome, Kira Dome, which is almost circular dome. This particular figure is not exactly the dome of the Kira Dome, but if you zoom the Google, I think you will see the similar figure. Okay, and it is dissected by several transverse fault systems along the across the strata. This is the distant view of the dome, and there is another hill. From the distance, you can see that is actually a basic intrusive body. Okay, it's a basaltic part, and at the because it is abutting to the north by Kachchh mainland fault. Okay. Another interesting part, another interesting feature, and very complicated domal systems, very complicated fault system is South Wagad fault, and which is considered to be the most active in the present day, because 2001 earthquake occurred exactly at this point, end of this South Wagad fault. South Wagad fault system, to understand it intricately, we must understand the subsurface structures, which until 2001, it was not very much clear. It was obscure, but after 2001 earthquake, based on the seismotectonic studies, based on the geophysical studies, the subsurface structures of the South Wagad fault and flexure zone, and their connection with the Kachchh mainland fault. You can see the Kachchh mainland fault and South Wagad fault, the total distance between these two, an echelon kind of fault, is not more than 20 kilometers. So the KMF is basically continued to the east, and it merged into the South Wagad fault. But this is called the same kind of fault system, but it is kind of Caesar faults. So this particular Caesar fault generated in the later phase. Later in the sense, a beginning of the Neogene, it has been started separating in the form of the kind of Caesar. So South Wagad fault as Caesar to the little bit of north, and KMF is to the south. Okay, so basically this is a part of the majorly, it is a same fault system, but in the later phase, when the strike slip component is added during the northward anti-clockwise motion of the Indian plate, this particular fault is generated. So that is why maybe it is very complicated in terms of their nature. Let us look at this fault. It is not a single fault, but to the south there is a fault. There are different names of this fault called Adoi fault, then Chopadwa fault, sorry, Chitrod fault, and then the part of it is also called in a different name. But the northern branch of this fault is called Kanthkot fault. So basically, it actually merges into one point it has a two branch, and again it merges at one point, then again it has a two the branching, again it merges at a 2 point. So we have a single fault structure, we have a double fault zone, we have again single fault, we have a double fault, single fault, and then is a single fault. So it has a single and double fault zones. So this is, we have mapped during the last few years, 5 to 6 years, this particular fault zone is mapped thoroughly with the help of the all neotectonics to active tectonic features. But what is important is the activities, seismic activity along this fault, and which is why the 2001 has occurred here, and that is why it is very vulnerable. And we come to know that where there is a two fault meets, becomes the single fault structure. This is much vulnerable. Where there is a double fault, it is less vulnerable. So this is that South Wagad fault. We have not gone into the details of in 40-50 minutes, but I would like to show some more cartoons from which you can understand the subsurface geometry of the South Wagad fault, complex fault systems. It is mostly following the kind of the positive flower structures and negative flower structures. Almost all the anticlines and domes, they are following the positive flower structures, as the South Wagad and KMF. Almost 20 domes and some 7 to 8 domes along the South Wagad, they have positive flower structures, and some depressed areas between these two faults, SWF and KMF. You can see 2001 earthquake epicenter is exactly between these two, which particular portion is called Samakhyali Basin, which is a depressed area, and it is found by the subsurface studies, found by the seismotectonic signatures. It is a negative flower structures, kind of the ranching the fault activity, faultings are there. So this is basically the signatures of the India's anticlockwise motion and the strike slip stress patterns along these two major fault systems. Now, let us look at the ground reality, where exactly how these faults and related anticlines and synclines they look. So Adhoi anticline is like this. We have a large anticlines along the Adhoi fault. Adhoi fault is nothing but a South Wagad fault. Now this is basically the end of our IBU KMU system. Now we enter into the new system of the late Eocene to Pliocene post-collision transpressional tectonics, wherein we have a structural inversion, thrusting of the block along the existing faults, and the fault propagated folding in the ductile sedimentary layers. So we will see some of the crucial sites and very important sites. I think I don't know whether I have given the justification to show those sites, but I have few slides. And the later in the phase, we have a Pleistocene to recent. We have active inversion, active tectonics, and the paleoseismic signatures related to this Kachch Basin. And we have also topographic rejuvenation and present-day topography. So in this phase, particularly Pliocene, Eocene to Pliocene, we have large number of the transverse fault systems developed, and they have dissected the Kachch mainland fault and the other faults, east-west faults, into northeast-southwest, north-south, or northwest-southeast fault systems. And they have somewhere dissected the stratigraphy also. But what happens to exactly at the fault zone, that is very important. Look at this fault zone, which is actually a Kachch mainland fault, KMF fault zone. In this picture, you will see the Matanomad formation, which is actually the Paleocene formation, and we have a Deccan Trap here. So this particular formation, which is called the Paleogene formation, which is uplifted along the exactly along the fault, it is standing vertical. And even Eocene deposits also standing exactly vertical, parallel to the semi-vertical to vertical fault plane of KMF. So this is very important that post-Eocene, these activities, KMF activities have been occurred. Bunny half graben is one side and the Kachchh mainland is another side. In between, we have a Kachchh mainland fault. The fault, Kachchh mainland fault. Now, why we are showing it to you about the Kachchh mainland fault, and it's a tearing movement. The Kachchh Basin is so beautifully shown as a textbook. It is an open textbook. I would like to share to everybody, all structural geologists, that it is a textbook for you, for everybody, those who are studying the structures and tectonics as well as the stratigraphy. Look at this Kachchh mainland fault here. What is the trend over here and what is the trend over here? It is totally tearing. So tearing faults which dissects the Kachchh mainland fault. Okay, so these are generated later on in the Neogene, earlier Neogene period. So this is very important in terms of the understanding the strike slip tectonics and post-collision phase tectonics. So these are the similar pictures. We have Fulra limestones, which is standing almost to the vertical, to the parallel to the fault. Now this phase, Paleocene to recent phase, I would like to show you quickly because it is, I think, almost 5 o'clock, but I would take more time, 15 more minutes. Sir, is it okay to show you the young tectonics? Because if I don't show you the young tectonics, which is very significant of the Kachchh Basin to show the intraplate tectonics and the active intraplate tectonics all over India, which is very significant. Let us look at some of the active faults wherein the faultings or reverse faulting is preserved in the quaternary sediments. You can see here the quaternary alluvial fans and the gravel facies. They are cut by the F1 and F2, two faults, which is exactly sitting on the control hill fault. This is control exactly. If you go down, this is the Juran formation, and right side down is Bhuj formation. So exactly this line is a control hill fault, exactly over which this particular fault is reactivating and propagating into the quaternary faults. So this is the only very confirming evidence of the neotectonics and the nature of the control hill faults in the later phase in quaternary period, which is one of the best example in western part of India. Now, the neotectonic signatures, as you know very well, and neotectonic is the broad terminology for the quaternary periods tectonic activities, and basically the quaternary periods tectonic movements, which is not much preserved in a kind of very active environment. You can have rarely preserved quaternary formations, which I have shown in the earlier slides, but you can have some of the preserved locations where the related landscapes, you can study the landscape if you don't have very good quaternary patches. So the landscape development itself will give you their activeness. So Kachchh is the place where we get the landscape features related to the active tectonics all over along the Kachchh fault and the Kutch mainland fault. So the scarps have very distinct feature, which are accompanied with many other features. In the later phase, we can see they are accompanied with the some of the sediments, shadowed sediments, having the colluvials and alluvial fan systems, and the gorge, deep gorge systems, which is generally you don't get in a very quiet area. Always in the active fault systems, along the active faults, we get these kind of gorge systems. And here we have a kind of incisions of the fluvial deposits. So these particular preserved fluvial deposits in the hinterland area will give us the story. But this particular story, we have only 18,000 years of the story we could generate from this particular fluvial deposits. But at least of the last LGM period, okay, we could generate the story of the tectonic story and climatic story of particular this area. But beyond this is very difficult in Kutch, because the climate is so harsh that in one particular, because we have an open rock system, and when there is a flood, there is a wet period, we have a huge flood and we have a flash flood system. So it raised the entire quaternary. So we have the preservation of the quaternary is very less. If you open the book of some of the tectonic geomorphology, you can see such features, and we have a textbook kind of tectonic geomorphologic features. Nothing to say about it much more, but just figure will say you many things about the mountain fronts and fault scarp morphology. There are major evidences of the nick points and gorges, which is seeing is the believing. So once you come here and look in with your eyes, seeing with your eyes, that is only believing. The photographs in the books or in the presentation will not fetch you good understanding, I tell you, and not satisfaction. So let us look at broad pictures of several other textbook fault systems, where we have normal systems to rivers, and which is a varied things. It may be old, it may be young, to the quaternaries, late quaternaries. It may be old, some inconformities are there. So the Kutch is the natural museum of the geology. Say sedimentology, structures, tectonics, paleontology, stratigraphy, or ecology, or you say any subjects, micro to vertebrate paleontology. But now we concentrate much upon the tectonics and the structures. So now I would take you to the seismic, that means last few hundred years or few thousand years of the tectonic history, earthquake history. This particular picture, you can see the latest earthquake, 2001. Before that, we have 1956 Anjar earthquake. This is Bhuj earthquake. 1845 is called the Kori Creek earthquake. Then 1819 called Allhaband earthquake. You can see a small feature within the Great Run of Kutch. Okay, just remember this. In the next slide, I will show you more elaborately. 1668 Debal earthquake and 1030 earthquake in Pakistan, Indus earthquake. I think it is called Indus earthquake. There are many. I have not included most of the earthquakes. But if you see the seismic behavior and epicentral location, I have not shown, sorry, but most of the seismic, earthquake epicentral locations or aftershock locations, they are around the 2001 main shock, and it goes somewhere to the east, and some earthquake epicenters are in the island belt also. Let us go to the the paleoseismic picture of the of the Kachch. So I would focus more upon the Allahabad. Okay, Allahabad is 1819 earthquake. That is the only earthquake which has given, even today, you will see the deformation, surface deformation quite nicely. After 200 years of this earthquake, today, if you go to this particular place, you can see the signature of the 1819 earthquake quite clearly, with the rejuvenation of the run surface. There is no fault plane exposed, but the rejuvenation of the run surface, the division of the run surface, one is to the north, the other is to the south. The major issue of this particular Allahabad earthquake within the Great Run of Kutch is, I think now it would be clear to you that there was one channel of the Indus called Nara Channel, which used to come and flow to the Kori Creek. Here is a Kori Creek. Here is the Kori Creek. Okay, this Kori Creek was extended in terms of the river here, and it was a river system here. So it was a Kori River earlier, and here it was a Nara River, and it was meeting to Kori Creek. Okay, and along this channel there was a big scenery fort here. There was a big fort 200 years back, and it was a custom collection center, just as Lakhpat was the custom collection center. There were 7 custom centers over here, and the kings of Kutch used to collect the revenue. Those ships used to go inside, and we had a very great navigation systems. So during one earthquake, this large, long linear ridge developed. It actually uplifted by maybe around 6 meters and 90 kilometer long, 6 meter high, and around 16 kilometer wide. So this long ridge occurred in one major earthquake in 1819, 200 years back, that has blocked this channel and stopped the sweet water of the Indus going to the Kori Creek, going to Lakhpat. And it was a big change in the demographic systems, a big change in the economic system of Kutch. Okay, so this is one of the major earthquake deformation features, uplifted range. There was one scenery fort here. This part used to be a kind of creek zone, or the channels of the Kori Creek's channel. This subsided down by maybe 4 meters, and we have a large scenery depression. So one earthquake, 1,000 square kilometer area is subsided to the south of Allahabad, and long 90 kilometer track uplifted. Now look at this Allahabad's main axis from where Nara River was flowing. Look at this abandoned river system. This is abandoned Nara River. Today you don't see anything, no water is flowing here. This is scenery depressions, and you see the run surface has several gullies and newly formed first order streams. So we have a gullied surface. This is just young, youthful topography or youthful geomorphic expressions of the Great Run of Kutch. Okay, and look at close view, ground view of the of this Nara Channel, abandoned Nara Channel. So this was once upon a time used by the shipmans. It was a navigation channel to the Pakistan. This is the way to Pakistan, and this is the way to Kori Creek down. Now everything is desolate, merged into the Great Run of Kutch, and nothing is there. No man is living here. No, very few animal species are there. Even they cannot live because there is no water. These are some of the pictures just to show you how one earthquake can change the topography, change the stratigraphy, change the river systems, and change the economic systems. These are the gully erosions of the Allahabad uplift. These are the latest gullied erosions of the Allahabad, exactly on the axis, I have seen taken the photograph. You can see the tilted run sediments. These are all run sediments and tilted run sediments. This is exactly taken from the axis. You can see a little bit of the bulging and flexuring of the strata. We call them the rejuvenation of the surface in last 200 years. In 2001, so just after 200 years in the same basin, but the fault is different. Earlier was the Allahabad fault, this is South Wagad fault. But how the 2001 or the latest earthquake has changed the scenario and changed the stratigraphy of the Kachchh in 2001. I have given you a very few slides just to show the liquefactions, which is basically the part of the churning of the sand which is at the saturated zone, which is coming on the surface. Around a 10,000 square kilometer area of the Greater Run of Kutch and the plain of Banni, which has experienced liquefactions. So I have shown some of the major points where we could visit during 2001, just after 10 days of this earthquake. We have visited these areas with Dr. C.P. Rajendran, Kushla Rajendran, and some of the USGS people and some of the other countries, geologists, they came here to visit. So this is a large crater exactly at the Indo-Pak border where there was a big earthquake, 1819. But we have got the crater, liquefaction crater in 2001 at the place of the 1819 earthquake. So we could correlate the 1819 liquefaction as well as 2001 liquefactions. I think this is one of the best sites where we have studied the correlation of these two earthquakes and their liquefactions. There are some pictures where the bedrocks are also disrupted in 2001. So these are the pictures where bedrock are disrupted in the Wagad area. So these are some tent structures. For the first time, we noticed these tent structures in Kachchh, not only in Kachchh, but all over the world. Such kind of tent structures are very rare. And that is why when we worked with Professor McAlpin, Jim McAlpin, and this kind of structures he has incorporated in the latest version of his book, Paleoseismology. This particular lateral spread activities in 2001 is still seen in 2003 after 2 years of the earthquake. Okay, so this is very significant, but it is in the alluvial fan zone. This is not in the hard rock, but this is still there today after 20 years because it is preserved in the hard rock. Now look at this particular point where this girl is standing. Okay, after I think this is 2011. The same place we have a small stream. Everything is gone. Okay, and we have a small stream. So you don't know whether there was a small fault occurred here. It is now a small stream at the place of the fault. And I have given you just to show you how the liquefaction pipe looks. So some of the trenches where we got the large scale craters where it was basically confirmed craters because during the earthquake we have seen, but just to see the geometry of the craters, we have dig the trench after maybe 2 to 3 years. So you can see a very good craters or liquefaction craters, which may be many meters down. We use the GPR, but at 9 to 10 meters, we didn't get the basement of this crater. Okay, so this is very, I have given you the journey from the 200 million years of the opening of the rift till the 2001 earthquake. I think Professor Bose, this is okay because it is 5:20 in my clock. I will not go further into the sedimentary rock systems. I will stop myself. Is it okay, sir?